What's up, you little shits? So this week, Epic Games announced the next iteration of Unreal Engine, which is going to be Unreal Engine 5. Who would have thought that 5 was gonna come after? Dude, I'd love it if they just skipped 5 and just went straight for 6. And while it's cool that they announced the next engine and the future of games and whatnot, the thing that piques everybody's interest is the tech demo that they put out, where they showcased some of the new technologies that they've been making for Unreal Engine 5. And a lot of people have been asking me about it. A lot of people have been asking, what does that mean for game development in general? What does that mean for games that are going to be made in the coming years? What impact does that have in the industry? Because there were some really cool stuff demoed in that tech demo. So I thought I'd take this opportunity to just talk a little bit about my opinions on it, what we know, quote unquote, so far about the technology, and you know, various other things and stuff. Come for the things and stay for the stuff. The tech demo is really about a rendering demonstration, where they showcase their two main new technologies that they've implemented, which are called Nanite and Lumen. Apart from that, they also talked about their Chaos engine, which is their physics engine, and Niagara, which is their visual effects system thing. Those two are already kind of in Unreal Engine, so we kind of already knew about those two. But they did show off some improvements that they've done to Niagara and Chaos, so that's cool. They also showcased like better reverberation, that's a word. One thing I'm kind of hoping for in Unreal Engine 5 is that they'll have better tools for mixing audio in general, because right now, like, there are a lot of good tools for modulation in Unreal Engine, but they're not good like way to use mixing and stuff like that. They also do a bit of a fluid simulation, but the fluid simulation is kind of odd looking, to be honest, and it doesn't really look like fluid simulation. It looks more like waves. I don't think it's the best way to showcase fluid simulation in that demo, but that's not really what the demo is about, so it's kind of like brushed aside, in my opinion. And some animation improvements that they've done. So one of the technologies that they're showcasing is something they call Lumen, which is a real-time global illumination system. So global illumination is the way that light bounces around in the environment. So the way that traditionally has worked is that if you want to have any kind of global illumination in your scene, you kind of need to set your items to be static and then run that light simulation in that scene and collect that data, and then it will bake that information into the mesh itself. And then once you're playing the game, you can do a lookup. Nowadays, we also have real-time ray tracing, which have many different types of implementations to it. But what they're essentially trying to accomplish is how light behaves like it does in real life and how it affects stuff around things. So if you have like very dark objects, that will affect the scene, whereas if you have light objects, that will affect the scene and the lighting differently. So with Lumen, they want to accomplish real-time global illumination. There are technically a lot of ways to accomplish global illumination, and it seems like Lumen is a combination of various different GI techniques, whereas that's a combination of like sign distance fields or screen space global illumination. And by utilizing various techniques, they can save a lot of GPU time compared to doing traditional kind of ray tracing that we're doing right now. But some people have pointed out like there are trade-offs with all these implementations as well. Some people have noticed that there are, for instance, disocclusion artifacts throughout the demo. If you're watching as objects are obscuring other objects, it takes a little bit of time before that bounce lighting is updated. And it also seems to be that the way they achieve this is by kind of propagating light and caching it somehow, because people have noticed that as the light is quickly moving throughout the scene, it takes a bit while before the light propagates. So there are probably trade-offs with these techniques as well, but we'll only really know for sure kind of what those limitations are and what those different trade-offs you have to take in order to utilize some system like this. And the other system that they're showcasing is Nanite, which is a system to handle virtual geometry, so they can render a lot of polygons on the screen. And I mean a lot of polygons, rendering a lot of polygons. Some people have pointed out that this is very similar to something called mesh shaders, which was a technology that was unveiled by NVIDIA. And the PlayStation 5 has very similar architecture that would feature that, so they seem to match up. Where you take big meshes and you kind of bake them down, and you stream in parts of that mesh as you're rendering it. And what that allows you to do is that instead of rendering, big scenes with a lot of stuff in them, you're essentially creating LODs for that object, and then you're streaming that in as you're rendering. So like the demo itself is really impressive and it looks fantastic. But the main takeaway from all this is everything that they kind of promise in terms of development processes. Because the regular work process is that when an artist makes you know, an item, they can make it very high detail and they can sculpt like faces. It's going to be really expensive to render all those polygons that you create. So what we tend to do right now is that we downscale the mesh that they've created, and you bake how the normals are in that high fidelity mesh into a texture that's applied to the model. So you can do a lookup. So you can essentially have like a completely flat surface and bake information as to like what the topology of that looked like. And then when you're rendering, you can just do a lookup on that texture to see like, oh, this is how a light is supposed to bounce on this object, but it's still not rendering as many polygons. The problem with that is that you can only really apply, you know, topology in an upward angle. So if you have like a rocky volume, rocks can't have like curves inward and stuff like that. They will always be perpendicular with the surface kind of. So when we're doing like displacement maps and stuff like that, you can't really have like divots go inside as you would if you had like a small rock. If you're rendering a high poly object and it's tiny in the viewport, if you can fit, for instance, the whole model in the space of a pixel, then there's no point in rendering all those polys because it will just be wasted time on the GPU. And the way we kind of solve that today is by using LODs, which is level of detail, where you create smaller poly count versions of the same model. So the further away it is in view space, you load in a smaller version of that mesh. And it's the same thing, like you can automate the generation of LODs, but they won't necessarily always be perfect. So not having to do that, just having to like take your model, your high def model, and just put it in the game, and that's that, is a big pipeline process improvement for artists. Because there are ways to implement a lot of the stuff that's showcased in the demo today. Like you can still do, you know, fluid simulations like that. You can have all that chaotic rumbling and whatever. You can bake that information and create an animation of it and run it instead of actually simulating it. Like the bugs avoiding the light, you can still do that with particle effects, with volumes right now. But I think the main takeaway is that the promise of making tools more streamlined for artists and being able to like create these kind of environments without having to care about LODs and having to care about baking and stuff like that. The big promise for developers for this isn't specifically like that tech demo looks amazing. It's all these like different promises that they make in how the process of making all this would be streamlined. The byproduct of using this technique is not having to deal with normal maps or having to deal with creating LODs. But yeah, given the demonstration they've done, the main bottleneck right now is going to be production of those types of assets. And, you know, whether it's possible to scale that demo that they did to a full game. Because, you know, on paper, it's amazing. Like, if you don't have to care about normal maps, you don't have to care about baked lighting or, you know, that stuff. But there are always, like, these questions of, like, okay, but if you don't have normal maps anymore, because, like, we're using those kind of textures for a lot of different things. So, like, what kind of control do you still have? So does this mean that every game in the future will use this technology and, like, you have to implement this or you have to use Unreal Engine to be able to reach, like, make games in the future? Like, the option to be able to do all this stuff is amazing, but not every game utilizes every single, you know, fantastic rendering technique that's out there. I remember back when, like, deferred shading was a thing and everyone's like, no one's going to use forward shading anymore. But that's not the case. There are still games that are made using forward shading, even though that's a quote-unquote old shading model and stuff like that, because it works in certain scenarios. It kind of depends what you're doing, and that's going to be the case here as well. If you're not making high poly, you know, environments and you need that kind of global illumination and whatnot, but at the end of the day, it's another option and it's another tool that we can use. There are a few things that are question marks still for the people I've talked to about this. And that's stuff like, how will this affect hardware? Like, they showcased this on a PlayStation 5, and they're talking a lot about how this is possible because of the architecture on the PlayStation 5. Specifically the SSDs that they have, that Sony has made, so that they are able to quickly stream all this data so they can render it in this virtual geometry.
Hey, just a quick update that after I shot this video, yes, Tim Sweeney did tweet about it and said that this will run on the next generation Xbox and on high-end PCs, albeit it's kind of clear what high-end PCs mean, what kind of hardware that entails. But there's an update for you. So back to regular old scheduled content. All right.
But yeah, there are different things in the demo that leaves question marks for game developers. Like, are we gonna be able to use this on skeletal meshes as well? Because in the demo, they were really showcasing static objects and static meshes. Because when they're doing that demo where they're turning it off and showing like the noise, you can clearly see that the player isn't part of that virtual geometry. And also to get people on board on Unreal Engine, I guess, because this really hyped up everybody about Unreal Engine. A lot of people that use Unity were like, oh, I'm gonna check out Unreal Engine. That's also by the fact that I think the biggest announcement that they made this week was the fact that you'll be able to use Unreal Engine for free up to $1 million in revenue until you actually have to pay any kind of royalty. What the fuck? It's like too good to be true, to be honest. Out of all the things that they showcased this week, I think that's going to be the one that has the biggest impact on the industry. I don't know, we'll see. But I don't think like a lot of games will be able to move over to this new way of rendering it, because it will have a huge impact on, you know, artistically what your game looks like. They're saying it just works, but you know,
art that just works.
That's never backfired ever in the history of ever. So I guess we'll see in the future. Thank you for watching this video. This is a lot of rambling. Take care of each other, stay safe, don't drink and drive, and bye!
Without